Alright, I got called into a shop last week, so I thought I'd make a video about it. I got a case study here. We got 2013 F-150. The main complaint is that the airbag light is on and the door Ajar light comes on as well. Two unrelated issues, but we're also going to find a third issue. And these fairly simple fixes, but just want to really talk about the diagnostic process and how to really confirm really efficient ways of testing and how to really confirm our testing is correct. So just trying to be faster and more accurate. So I did a module scan on this, and I recommend you really just get in the habit of checking all modules anytime you work on a car. And so we can see what modules are on here, and there is a lot of codes in this car. So we're going to kind of go through some of the theory related with that as well. One of the things that wasn't a complaint, but we noticed, is that there's a P0072, and that's the ambient air temp sensor circuit low. So I'm just definitely going to try to take a look at that in this case study as well, because I want to make sure this thing gets fixed right. And the airbag light is on because it's got a left side airbag deployment code in it. We also see a restraints sensor code. And there's a bunch of low voltage and com codes. So we see a lot of communication codes here. Even more voltage and communication codes. Even more, will it end? Are we there yet? There's about 25 codes in this car. So time to do a little research and a little bit of, ask some questions of the shop here. So I know that there's a ton of low voltage and communication codes, so I'm just kind of, at this point, stopping, doing some thinking, come up with some strategy here. I find out that the battery was recently replaced and there was a lot of corrosion on the terminals, and this is a fleet vehicle, just by the way, and it wasn't an accident, front right. So we'll see how all these things, all these pieces of information played into this case study. So my strategy is to, clear the codes out. I documented it. I just hit that screenshot button a couple times and I got all the codes documented. I think that the voltage and communication codes could have been when the battery was bad, if there was corrosion and the voltage was dropping during cranking or whatever else. So we're going to really look at the three main issues that I see, and that's the ambient air temp sensor, the driver's side airbag, and then the door ajar complaint. By the way, there's no codes when you see how the circuit works. There's really no way for the PCM to really know that there is an issue with that door ajar light. So I'm going to tackle this one system at a time. So in no particular order, I decided to take a look at the airbag system first. And I did the key on, engine off self-test. And this B002013, that is an active, circuit open code. Now, I always preach to my students and when I go to training how important it is to understand code descriptions. Is it a circuit code? Is it a rationality code? Is it a performance code? Okay, this one's clearly a circuit code, but we also want to make sure as we are working on the right component. So this is kind of deceiving. When we hear left side, we think, okay, the left side of the vehicle. This is actually, this part right here means left side of the vehicle. This one right here means it's the side airbag in the seat. There is also a side curtain airbag as well. So it's important that we make sure we identify the right part here. And then we had some other, communication codes and a restraint sensor. So time to do a little research, pull a diagram, and we take a look. And, these airbag circuits couldn't be easier to diagnose. So we basically have two wires going to the squib. And so, if you don't already know, we're not going to check resistance of this squib because, the meter is going to take a little bit of voltage to do so, and we don't want to risk setting this thing off. So what I planned to do, and you'll see how it didn't work out for me, what I planned to do was I was going to disconnect the airbag and then put a resistor, 2 to 3 ohm resistor in its place here, or you could even short it out. Since our code, if you look, was circuit open, what you can do is you can short this out, obviously with the airbag disconnected, and then you can see if it goes to a short circuit code. If it does, one could assume that this wiring is good and that you maybe have an airbag module. If it doesn't change, then you probably have a wiring issue. So in order to get to the airbag, there's a zipper on the back of the seat. You have to zip and take off some of the seat cover. Well, I like when they're this easy, and when I unzipped the seat cover here, the wires fell out. So this is a construction vehicle. This is that single cab, but it does have quite a bit of room behind the seats, so the guy probably is throwing shovels back there and stuff. So this is a good starting point. What we're going to do is we're going to repair the wire. Now, full disclaimer, I repaired the wire just for testing purposes. Most manufacturers do not want you repairing airbag, ABS wiring, stuff like that. So what I did is I just connected it back together, but then recommended the shop put a harness on it. So the codes were cleared. It passed the key on engine off test. After that, we're done with this one. So that was an easy one. Now we do a little research on this ambient air temp sensor, and it's really just a really simple, basically a thermistor. It just changes resistance with temperature. The nice thing that we were able to find in the Ford service info was a temperature to resistance chart. So this here gives us the temperature and what you could expect a good sensor value to be for resistance. You'll see why I use that in a second here. This vehicle did a cold soak, so what I did is I compared some of the PIDs, and you can see that the cylinder head temp and the intake air temp are, correct and displaying the shop temperature, but the ambient air temperature sensor is reading 185 degrees. So going back to our chart, this chart, it's not even really in there, so it's just probably an open sensor, shorted. I'd have to look further into to see which one it is, but so the code sets if the sensor is shorted to ground or damaged. So take a look at the diagram. We have the PCM and wiring going to this resistor. Now, what you don't see in the PCM is another resistor in series and like a sensing circuit, and the PCM is monitoring voltage at this point here. So this resistor is fixed, this one's variable. The voltage at this point will change, and that's how the PCM is able to calculate the resistance value. So I wanted to go take a look at the sensor because my plan was to do a little testing at the sensor. And like I said, this vehicle was in an accident. The bodywork is completed, but this sensor, this is the temperature probe right here of the sensor, it got banged up, and obviously there's some physical damage. So slam dunk here as well. Most people order a sensor and be done, but unfortunately I'm going to tell the shop owner here what he needs to buy for parts and then leave. So I want to be absolutely sure this is the only issue with this vehicle, because you will see that I found a broken wire already. With the airbags, we're going to see some more wiring issues on this car in a couple minutes here. So I want to make sure that there's nothing else going on, especially if it's in an accident. That harness could be damaged. So what I did is I got these breakout leads recently from AES Waves, so I was able to put my leads here into the connector, and then that kit comes with a variable resistor. So I dialed it up to the max, which was like 10,000 ohms. And so if you look at our chart, you can see that 10,000 ohms is somewhere in this between 70 and 80 degrees. And then we go take a look at the scan tool, and the scan tool spot on shows 75 degrees. So that we could assume now that the wiring is good. And also did the key on engine off test with the resistor installed, and we got no codes. So I recommend a replacement of the sensor, but I was also confident in that was the only issue. So adding the resistor to kind of substitute is very helpful. Other times that it's helpful to add a resistor to a temp sensor circuit is if you need to, say, get a monitor to run. It's a 0-degree day and you got some monitors you need to run. You may have to trick the intake air temp or ambient air temp sensor circuit into thinking it's a little bit warmer outside in order to meet the enable criteria. I used to do a lot of Ford 7.3 injector tests. Well, these vehicles would barely start or run really poorly in the morning when they were cold, and then once they warmed up, you would never know that the vehicle had an issue. So it's a classic bad injector. However, you just don't know which one because a lot of times they would not code. So the test, there was an injector test. There is an injector test in IDS, and when you would do it, the engine had to be fully warmed up. So I would trick the temp sensor into thinking the engine's warmed up to allow that test to occur when the engine was cold. So, resistance substitution for temp sensors is a great way to test the rest of the circuit, but it's also a great way if we need to get a monitor to run or a test to run. We can kind of trick the computer. Alright, next up is the door ajar light. So the lights in the cab intermittently illuminate and a warning chime comes on. So the tech at the shop already lubricated the door jambs and no change. So on the scan tool, we quickly identify that it's the driver's door that's giving us an issue, not the passenger door. And so we take a look at this diagram here, and we can see that it's really simple. The left front door has basically there's another resistor, power, and sensing circuit here, and the switch either gives it a path to ground, or if it's Ajar, the switch opens. And so if the vehicle sees voltage at this point, they know that the door is Ajar. If they see 0 volts or close to ground, they know that the switch is closed. So what I'm going to do is I'm going to get to this switch, and I'm just going to jump it. And so basically simulating a good closed door switch. And so what I do is I access the panel, and I use my same cool kit right here, and I just jump the sensor. And I had no change on the scan tool. The door is still showing Ajar. So going back to the diagram now, basically I probably have a wiring issue. Anyone that's worked on cars for a number of years or is a pattern failure kind of person, they know where that wire is probably broken. So if you were going to go to Vegas and make a bet, you would probably go for the door jamb, right? Because the door jamb, the wire is always flexing back and forth. So I pop the boot back and I find a broken wire. Someone had already been in here and soldered a little wire in here. The issue is, A, their soldering joint was in the door jamb. So as the door flexes, it's going to be hard on that joint. And then B, they didn't even heat shrink it. So there was some corrosion built up and stuff, and that's kind of why the wire broke off as well. They electrical taped it. You would be better off, if it was a ground wire, you couldn't do this to a power wire. You're better off leaving a wire bare than putting electrical tape on it, because electrical tape allows moisture in and it just stores underneath there and rots away the connection. So the proper fix here is we de-pinned this wire right here, popped a new pin on and then a fresh wire, and made the butt connector connection inside of the door rather than inside the door jamb. So now we only have wiring in the door jamb, no butt connectors or solder joints. So scan tool helped us figure out which door was the culprit, and then we just jumped to see if it was a switch or the wiring. We found some wiring based on some pattern failures. So using some simple testing techniques, we were able to accurately and quickly diagnose multiple wiring issues on this truck. So the tests we used were just, not only were they quick, but they were really accurate. So it's just going the extra mile to make sure that the diagnosis is accurate and efficient. So I hope you enjoyed, and I hope you can apply some of these principles to your next diagnosis. Thank you.